Okay, what if I told you the Earth isn't just, well, a rock with life on it? What if it's more like a single living organism? A huge, interconnected system that's actively working to keep itself alive. I know, it sounds a little bit like science fiction, right? But it's actually the heart of a pretty revolutionary scientific idea. So let's dive in. So just imagine for a second a planet that regulates its own temperature, that keeps its own atmosphere breathable, and its oceans perfectly stable, all by itself. This isn't some fantasy novel. Nope. It's a real scientific framework, and it's called the Gaia Hypothesis. And trust me, it completely challenges how we think about our world. All right, so let's go back to the 1970s. A scientist named James Lovelock, working with the amazing biologist Lynn Margulis, came up with this really wild idea. They said, hey, what if life isn't just passively adapting to whatever Earth throws at it? Instead, what if life is an active player? Partnering up with the air, the water, the rocks to literally build and maintain the exact conditions it needs to survive. Pretty cool, huh? Okay, so what does that even mean? The planet behaves like it's alive. Let's break down what the Gaia hypothesis actually is, and just as important, what it is not. First things first, let's get a huge misconception out of the way. Gaia does not mean the Earth has a mind or a consciousness or some grand plan. It's not about the planet thinking. It's about the planet doing. The idea is that the whole system, all of life, plus its environment, acts together like one big self-regulating machine. See, Lovelock was a real puzzle solver, and he started noticing all these things about Earth that just didn't make sense. For one, our sun has gotten way, way hotter over billions of years, yet Earth's temperature has stayed surprisingly stable, nice and cool. And then there's our atmosphere. It's this crazy reactive cocktail of gases, like oxygen and methane, that chemically should not be able to exist together. To Lovelock, these weren't just weird coincidences. They were clues. Clues that some kind of global system was working behind the scenes, actively keeping the planet in balance. But how? How could life regulate an entire planet without having a brain to coordinate everything? Well, to show how this could happen totally automatically, Lovelock came up with this brilliant little thought experiment, a computer simulation he called Daisyworld. So, picture this. Daisyworld is a super simple planet. There are only two forms of life here. Black daisies, which soak up sunlight and warm the place up, and white daisies, which reflect sunlight and cool things down. And both kinds of daisies have a sweet spot, a perfect temperature where they grow the best. So, what happens if the star Daisyworld orbits starts getting hotter? Well, the whole planet starts to warm up. All of a sudden, the white daisies, the ones that reflect heat, have an edge. They start to spread like crazy, while the black daisies, which absorb heat, start to die off. But you see what's happening here? As more and more white daisies cover the planet, they reflect more sunlight back into space, which actually cools the whole planet down again. The point is, the daisies work together like a planetary thermostat, and there's zero conscious planning involved. Just like Lovelock and his colleague Andrew Watson said, Daisyworld is a kind of parable. It's this beautiful illustration of how global regulation can just emerge automatically. It happens just from organisms doing what's best for them. No foresight, no grand plan, just simple, blind competition creating a stable world. Okay, so Daisyworld is a really cool model, for sure. But does this kind of thing actually happen on the real Earth? Well, let's take a look at some examples that suggest it absolutely does. And yeah, we see systems like this all over the place. Take the tiny phytoplankton in the ocean. They release this gas, dimethyl sulfide, that helps create clouds. More clouds mean more sunlight gets reflected back into space, which cools the planet. Sound familiar? It's just like the white daisies. Or think about rainforests. They literally create their own rain, maintaining the exact climate they need. So you see, life isn't just a passive passenger on this planet. It's a crucial part of the climate control system. And the sheer scale of this regulation is just mind-blowing. Scientists figure that since life began, the sun's energy output has gone up by about 30%. 30%. To put that in perspective, that's enough extra heat to have either frozen our planet solid or boiled the oceans completely away. And yet, Earth's temperature has stayed remarkably stable. This incredible long-term stability might be the single most compelling piece of evidence for some kind of planetary self-regulation. So, what's the verdict? Is Gaia real science, or is it just a powerful metaphor? This question, my friends, has kicked off one of the biggest and most heated debates in modern biology. On one side, you have the supporters. They argue that Gaia is pretty much the only thing that explains Earth's incredible long-term stability. But on the other side, you've got critics, especially old-school evolutionary biologists, who have a huge problem with it. They say it sounds teleological. That's a fancy word that basically means it implies Earth has a purpose or a goal to stay alive. And that's just not how evolution works. For them, natural selection is all about what helps individuals survive and reproduce, not what's good for the planet as a whole. The famous biologist Richard Dawkins really hit the nail on the head with this criticism. He basically asked, why would any single organism spend its precious energy making something for the good of the world? In a dog-eat-dog Darwinian world, any selfish individual who didn't bother would have an advantage, right? They'd do better, have more offspring, and their lazy genes would win out. Cooperation on a planetary scale just seemed like a total fantasy. But Gaia's co-creator, Lynn Margulies, had a pretty sharp comeback. Her vision of Gaia wasn't some kind of gentle, nurturing Mother Earth. As she so famously put it, Gaia is a tough bitch. Her point was that this isn't some nice, feel-good system. It's a brutally effective one that has kept things stable for over 3 billion years, long before we humans ever showed up, and it'll probably be here long after we're gone. So, over the years, this whole debate has actually helped refine the idea. Today, we talk about two versions. There's strong Gaia, the idea that Earth is a literal, thinking superorganism. And yeah, most scientists don't really buy that one. But then there's weak Gaia. This is the idea that self-regulation is just an emergent property, something that naturally arises from all the complex feedback loops between life and the environment. And that version, it has gained a ton of support. It's actually a core part of how we study the planet today in Earth system science. And to be clear, the critics have some really strong evidence on their side. A scientist named James Kirshner points to data from ice cores that shows during past ice ages, greenhouse gases like CO2 and methane actually made the climate swings worse, not better. That's the exact opposite of what you'd expect from a stable, self-regulating system. He also points out that evolution often leads to what he calls biotic plunder, basically organisms using up resources so fast they wreck their own environment. Plus, look at what's happening now. The planet's biological response to our huge spike in CO2 has been pretty slow and weak, which doesn't exactly scream powerful, self-correcting system. So where does that leave us? Well, the modern view is this. Gaia isn't about a literal truth, but it's an incredibly powerful framework. The Earth isn't biologically alive, no, but it behaves like a single interconnected system. And that's the real value of Gaia. It forces us to see the bigger picture, to understand that you simply cannot separate life from the rocks, air, and water that it's a part of. And that brings us to a pretty profound final thought. Maybe the real takeaway from the Gaia hypothesis isn't answering, is the Earth literally alive? Maybe its real power is the question it makes us ask ourselves. In a world where life and the environment are so deeply, fundamentally tangled up, can we even draw a line where one ends and the other begins? And thinking about that, well, it really changes how you see yourself and your place on this incredible planet.